Good morning, good evening, good afternoon. Here we go, logo in place. Good morning, I've said that already. Welcome to Going Meta episode number 10 of season 3. Today a little bit different, I would say. Jesus has an emergency meeting today, so Will was graciously available today to jump in. Will Lyon is a senior product manager at Neo4j. I'm very happy to have you here with me today, Will. Welcome to the show. You've been here before last month, so repetitive viewers might remember you, and probably Neo4j followers have seen or heard from you in the past. So I think you are one of the known faces around Neo4j. But nevertheless, you are focusing on in your work as a senior product manager. You're focusing mainly on, if I'm correct here, and correct me if that is not the case, but all things around AI tools, AI in integrations with Neo4j, mainly I think Context Graph was one, memory service was another one that has been up on your plate recently, and probably you can share a couple of other things you're currently looking at the moment.
Yeah, happy to fill in for Jesus today. That's right. I'm a product manager on we call it our AI innovation team, right? So we have lots of different product teams that look after pieces of the core database, the query language, things like this, and in our Aura platform around this. And I'm on the team of product folks looking at how we can make our graph intelligence platform sort of the best place for working with data around AI use cases. The pieces that I've been looking at have been, like Alex says, the AI agent memory, looking at this context graph idea. I guess really maybe a way to summarize like the area that I'm looking at is, what are tools and services that we can build on top of Neo4j and on top of the Aura graph intelligence platform to make it easier, more efficient to build, orchestrate, operate your agents. And a lot of that now, a lot of the interest now is making sure we have the most relevant context and bringing, the sort of like context layer to your AI agents, whether that's through agent memory, some semantic layer mapped across knowledge throughout your organizations. But yeah, lots of interesting things to work on in AI agent land. I just came back from, and Jesus was too, the AI Engineer World's Fair in San Francisco, which is, I think of as kind of like the center point for a lot of this like AI engineer discussion, right? So lots of new learnings and good ideas there.
Definitely. I wanted to, before we dive in, I wanted to touch base on this a little bit. I talked to our colleague ABK Andreas from the developer relations team here at Neo4j as well, and he said one of the the things that stuck to him mostly, and where I was surprised as well, was one session at AI Engineers that was a professor giving a talk about how ontologies are, and this is obviously fitting for this series, how ontologies, and I cannot even put the exact title now from remembrance, but something about ontologies and AI agents and how it's necessarily the two work together, and an AI agent, a proper AI agent, was basically the verdict, is not working without an ontology. So I don't know if you attended this session or if you heard about this, but this is probably some of the things where we've been, in this series and beyond at Neo4j, we've been talking about this a lot, and we think, okay, this is the crucial bit that you have to make sure, and it's now coming from all sides, which is really good to see.
Totally. There were several sessions, I think, that had a similar theme to the one you're talking about, and we also did a graph gathering with like-minded graph folks, kind of co-located around the conference, and had an unconference discussion. And this idea of like how are ontologies relevant in the AI agent world came up quite a bit, and I think there are a few different aspects to it, but I think like the most foundational one is that working with AI agents, there's a lot of unstructured data, right? So think of like messages, chat messages that we have with the agent, the reasoning traces, right? That from the agent, right? Like a lot of like text, and in order to like help make sense of this text, like constructing a knowledge graph is I think one of the highest value things you can do. But in order to do that, right, in order to take this unstructured data, find out what are the entities, how are they connected, you need to have some understanding of like the domain of the data and how this knowledge graph that you're going to surface, how that's going to map to your business data as well, right? And I think this is where the ontology comes in. If you have some structure, some map of your data, you can use that during this entity extraction and resolution process to have like they call it like an entity resolved knowledge graph, right? Like can this be grounded in an ontology that describes the shape of your business? And folks are realizing this is really key to drive the quality of that knowledge graph that you're constructing. And so yeah, a lot of discussion both at the graph gathering around how are we leveraging ontologies in this, but also at the conference in general. A lot of chat about like ontology driven knowledge layers, this sort of thing. Yeah, sure.
Yeah, very cool. I like that this is taking place, and this is not that the threads are aligning here a little bit, or converging even, where you say, okay, we are talking about this, and everybody thinks, okay, ontology is important, but then it's sometimes kept in this secluded space. But now we think, okay, let's open this up. It's really important as a foundational pillar, and then you extend it into a knowledge graph, extend it into an agent memory, and interweave it all with a knowledge graph knowledge, all these bits come together really in a way that I think is really important, and really a really interesting development in the just recently, I would say last couple of months, even.
For sure. Yeah, I mean, I think like the benefit that you get from an ontology can be real, right? But there's a lot of potentially a lot, upfront costs that you have to factor in to think about, how do I draw the shape of my business data, and I think that's been a blocker in the past. That do we spend the time up front to map this out? How can we agree on like what is the definition of a person throughout my enterprise, right? And I think this threw off a lot of projects, but now the AI agent tooling, the right, like coding agents, like all of this can make working with some additional complexity perhaps a bit more manageable. And so now I think we're seeing the complexity and the cost of like managing an ontology is now, like, I think for a lot of cases greater. Or the cost is much less than the benefit that we're getting, right? Because we can use AI tools to help us even automate the development of the ontology. This is one thing that that came up, especially at the graph gathering, was like, okay, how do I bridge this? Maybe have best of both worlds of like, I don't want to spend a bunch of time up front mapping out my ontology, but I'd like to take advantage of that. Is there a way that I can have an AI agent help me evolve the ontology and govern that as I'm discovering the type of data that I'm working with? And that is actually maybe, I think, where folks are looking going forward, is like, how can we have the best of both worlds, have like a strictly typed business ontology, but maybe have the AI help us evolve that as we discover new information and new uses going forward.
Yeah, definitely. And I think it's like you said, and then we can pivot here. But I think exactly what you said is true. It's been painful. It's been a lot of upfront work. It's been very hard to get going. But if you have now the possibility to take a standardized ontology and then with a bunch of iteration make it yours through the help of AI, I think that can be really the so-called and often called game changer, but I think it's true in this case.
Totally.
Before we dive in today's topic, there was another question in chat. We can maybe quickly also pick up, since this is another reminder to everybody who's watching this live. Is supposed to be interactive. So if you have questions, comments on anything what we just said, or generally on the topic, or about AI context graph of today's topic, maybe let us know in chat, or just say hi, like Pavel and Darlan did. But if Fred Paul asked the question, and they wanted to know if we could talk a little bit about the Google's new open knowledge format, and we quickly discussed it. I haven't heard about this before, I must admit, but you said, Will, you have heard a little bit about it. You could cover a little bit on it. The question was if it's working, or how would it work with Neo4j? Is it redundant? Does it provide any benefits? Anything you can think of in that direction, or should we table it for later?
Yeah, we could maybe take a look at it just briefly, and maybe this is a good pointer for a future demo that we could build some Neo4j integration. This is something, that we saw from Google, I want to say just a few weeks ago, right? And I think they put out this open knowledge format, OKF, which draws together some common ideas, right? There's this LLM wiki pattern going around. I think Andrei Karpathy had a popular, I don't know, Twitter thread about this idea, right, of just like taking a whole bunch of data and constructing like a LLM wiki, but referencing connections, like referencing relationships. So if folks are familiar with like Obsidian or any of these like personal note taking that use Markdown, let me see. There's an example in here. Yeah, like a lot of them will use, like you have references to other. In this case, everything is Markdown, right? So you have like a Markdown file like per concept, and some like folder and file hierarchy, which is another pattern that I think is kind of emerging for progressive disclosure of kind of allowing AI agents to work through a large corpus of data. But like Obsidian and other of these like personal note-taking apps like have this concept of linking to other concepts and documents like within Markdown. This concept of every Markdown document represents one concept and has some front matter, right? So we can like tag these, and tags then become a way for you to like group and follow things in the graph. And so really, I think my understanding, I haven't dug into it too deep, but the OKF open knowledge format is really just a way to take some of these common patterns that are coming up of this mapping of giving an agent a file system to explore, right? Agents are very good at navigating directories and this file structure, and then in within the front matter, having some YAML block that has some metadata about the concept. Tags are an important concept. Links to other concepts are important, because then you can construct the graph of these things as they come together. So I think that's really my understanding of Google's OKF is really trying to have a flexible but still somewhat standard around this LLM wiki pattern that's evolving. And I think it's flexible enough that you can you could put a sort of file system abstraction over different types of data stores, right? That's something that we think might be interesting to explore. But yeah, I haven't done too much here. I know there have been a few folks at Neo that have dug into this in a bit more detail. I think of maybe it's just some way of having structured references between concepts, and it'd be interesting to see where that goes. Yeah, for sure. But yeah, I think we'll probably see some demos and examples, and maybe some example from the Neo4j folks. We've seen some chatter about this, but yeah, I think we haven't had like there's been a lot of effort around these LLM wiki, right? Like, can you parse a whole bunch of documents, extract out the entities, load them into Neo4j as sort of a graph of concepts type thing. But yeah, it'd be interesting to see where this goes.
Definitely. Yeah, good point. I took a note, so maybe for one of the future episodes here or on other formats on the channel could be something to look at. But if you see this more and if you think this is interesting, let us know. That gives us a good indication if that is something you're interested in. Generally, if you have any topics, any feedback in particular, but also obviously recommendations for topics to explore. YouTube comment section is a great gathering point, obviously, but also Neo4j community forum and other places. Just tag us and let us know if something is on your mind you would like us to explore some time, and we can see if it fits the program. But yeah, with that out of the way, sort of, the topic today is actionable knowledge for agents with context graph. So that is a little demo set or a demo. Well, here it is in a way. Demo you built. Did you do this for the graph gathering last week, or was this an AI engineers talk even?
Yeah, exactly. So a lot of this comes out of I gave a talk at AI Engineer World's Fair about this, and some of the work we've been doing in the Neo4j agent memory service within Neo4j Labs around skill distillation is I think really the origin of this work. So yeah, I thought it'd be fun to maybe talk about what we're doing here and show a little demo and answer questions as they come up. But yeah, happy to explore that in a bit more detail. Cool. Should we just jump in?
Yes, let's go. Yeah.
Cool. So to maybe set up the stage here before we take a look at how this works, let me go through a few slides just to talk about kind of how we think about agent memory and some of the tooling we have around that. At AI Engineer World's Fair, there in the larger AI engineer discussion in general, there's a lot of chatter about loops, right? Like the React loop, the Ralph loop, and sometimes I feel like we're in this like amnesic loop where our agent has this like purposeful step to like forget all the useful things, right? And I think when we add agent memory to our agent, this is like roughly the pattern that we're following, right? Is like we're doing some embedding, we're fetching some data based on some like vector search, and we're like injecting text into the context window, right? And our like vector search says like, hey, this is the most relevant context because it's similar in vector space, but there's a lot that we're missing out on, right? So like for example, and this is a good one. We were talking about why do we have an ontology to help us during knowledge graph construction. Like in a conversation with an agent, we might refer to Dr. Nguyen, Robert N, the cardiologist, right? Like these are all ways that we might refer to the same individual, but we need like some canonical representation of this concept of in this case a healthcare provider, right? And so we've built some tooling within Neo4j Labs, and also see a lot of patterns that folks are following that look very similar to this, right? Where you have different abstractions around the type of agent memory that you're working with in the agent memory, Neo4j agent memory package, and our Neo4j agent memory service within Labs. This is the graph data model that we use. So short-term memory, this represents the scope of a conversation. So think of this as a maybe like a linked list of messages. And then long-term memory, these are the entities and the connections between them that are extracted out from your messages. But then there's a third type of reasoning third type of memory called reasoning memory. Other folks, this might fall into like procedural memory is other terminology that's used to describe this. But essentially, think of this as capturing the reasoning traces, the decision traces, like what tools did your agent did call, some observability metrics, how many tokens did they use, how long did it take, what was the whole execution and planning path of resolving some task. And that's tied back into short-term memory, which is the message that kicked off the task, right? So this is how we think about agent memory and Neo4j, this connected graph of different types of memory. And together, these become a context graph, which I think makes like a really interesting substrate now for data for your agents. So let's look at a few examples of kind of what this looks like in a bit more detail. So here's a message that in the healthcare space, and I think, by the way, my example is going to be healthcare. So imagine that we're in that space, that domain, and we're talking about like a healthcare provider and some medication. So we need the ability to extract that into some structured graph, and having typed entities, the typed relationships, right? This is like the core piece of what makes an ontology. Like what are the type of the things, the concepts, the entities, and then having a well-defined range of relationships between them that ensures that in a conversation, as we refer to the same entity with different text, different context of the message, right? Like we're able to resolve that entity. And as this case, this is not necessarily just a person. We want to understand like, oh, this is a provider in our healthcare ontology, right? And so when we have that shared now with multiple agents and across our domain data, we're able to join and combine those to be able to query across knowledge graph extracted from conversational data, but also our domain data. So that's a bit of the like knowledge graph long-term memory, but we also have this idea of reasoning memory that I talked about, right? Where we're capturing like decision traces, what the agent actually did. And this is important because we can make that available to our agent or other agents in a shared memory system. So the agents are able to learn not just from what they did, but what from other agents within our enterprise have done. And this is where the concept of the decision trace comes in, right? So every time that an agent goes through the reasoning phase, we're recording the reasoning step, the tools that the agent is calling. That tools are how an agent interacts with and understands its environment, right? So at every like reasoning phase, it's a question of like, do I have enough data to respond? Do I need to call some tools to fetch more data or change a state? Which one should I call? And that's kind of the reasoning phase, the planning for the agent is in this world of all the tools that I have available. How do I want to kind of piece those together? And if we can provide the agent with an understanding of, okay, and throughout the organization, when we had a similar problem before, this is what we did. That's kind of what reasoning memory is all about.
I think this is, sorry to interrupt you, Will, but I think this is an important thing to iterate and to keep in mind, that this is so important, because otherwise, you get a roll of the dice. Oftentimes, you have no clear, path of why a decision was made, who made the decision, what was the reason behind something, like a yes or a no, in any kind of way. And if that is stored, and if that is something that an agent can call back and say, okay, before this, 5 out of 6 times this was the way, then probably this is also the way now. This is much more, much more relevant, but also more what's the word here? More more foundational, basically, as a path for something like this. So, and I think, and I don't know if you touch on this, and then we'll see about this, but oftentimes people when I talk to people, what's top of mind nowadays is obviously this traceability, this repetitiveness, this predictability again of what are my agents doing, but also what comes up now is how much do they spend? Is it gonna be very, very, very expensive? And if they repeat the same task over and over and over again with lots of tokens unnecessarily, obviously you have an issue. And if you can just say, okay, this is how it's done. Do this, repeat this. Don't come up with crazy ways. Just this is what I want. It's just saving and predictability, I guess. So very, very good.
Totally. I think you hit a lot of the benefits of adopting this sort of pattern, right? And it's certainly the case where we need that explainability, the auditability of, okay, some decision was made, like what policies served as precedent for that, and can we document like the rationale for that. The determinism piece also I think is something folks are looking to have, something beyond like an agentic flow where we really have some actual like reasoning, but let's have some sort of confined scope of what we're actually going to end up with, right? Like some determinism around that. And then I think the third one, which we're seeing more and more now, is this token efficiency, right? I think folks are at the stage where, like, okay, yep, I've built my proof of concept. It works. It's great. I want to go put it in production and scale this up. And in order to do that, I need to make sure that I'm, have cost controls, that I'm being as efficient as as I can. As I think, like what we're seeing is like the cost of a token for the frontier models is continuing to go up as these models get bigger and bigger, and we're seeing things like some of the subsidies from the AI labs maybe start to dry up, and it'll be really interesting to see like as compute, the demand for compute continues to grow, but perhaps becomes more constrained. Like I think we're going to see a lot of folks wanting to focus on this token efficiency piece, and it's really interesting to see when we were at a customer a few weeks ago that put this sort of like reasoning memory proxy type situation into place, and they had like a 33% token reduction in the example that we had put together in a week. So yeah, so there's some real benefits here for sure. Cool. So let's talk about actionable knowledge a bit. We talked through kind of how we construct the memory graph, the distinction between like short-term, long-term, and reasoning memory, and the benefit of capturing these reasoning traces and sharing this information across not just like one agent, but across like multiple agents in your organization. So that's how we think about memory. And I think like if we think of the context graph that we're constructing of short-term, long-term reasoning memory, this data that we have, we can certainly like make that available for our AI agents to fetch during their reasoning phase, right? We have a number of tools for retrieval of searching through different types of memory, and like that's fine. That's useful. But what is more interesting, in my opinion, is how we can sort of distill actionable knowledge, like from the memory, from the context graph that we've constructed. And skills are one way to do that, right? So skills, this is a standard that Anthropic put out. I think we have, here we go. We have a slide on that. And really think of a skill as some portable instructions that have some like associated, often like reference data. We can have scripts or code as part of like a skill bundle. And we start as like an entry point for the skill is the skill.md file, which has like some high level information about what the skill does, what it is, and then there can be additional references and code. But it's some like portable standard essentially that for example, there's a skill for creating PowerPoints, or at Neo4j we have a bunch of skills for how to construct Cipher, or how to work with data modeling and different things like learnings and sort of actionable things like packaged up, and is what this concept of a skill is all about. So there's been like some really interesting research and work to evolve the skill spec and make sure that this is useful across different agents and different use cases. I think one area that some folks at Neo4j on the research team have been looking at is what happens if we model a skill as a graph, right? So the default is like, okay, we have a bunch of pros, a bunch of markdown. We have like some progressive disclosure, so we can say like, okay, I want the more text that tells me how to style my PowerPoint slide or whatever, and I know, I go open that file if I want to load into context like all this additional information, right? So that having those relationships there, like that is a graph. We talked about how we have like steps in the skill that could map to like scripts and code that we want to run. Like think of the dependency there as a graph. So what happens if we model our skills as a graph? Like can we make them more deterministic? Can we improve sort of the effectiveness of a skill? And so that's some of the research that Zach and Jim on the Neo4j research team published this APE. So the APE paper, Agent Instruction Protocol, and that's kind of what they were looking at. Like if we break down some of the steps in this prose representation, instead of just as text, instead if we treat our skill as a graph with dependencies between the different steps there, can we sort of have a more efficient skill and more portable skill? And what they found is that some of the issues with a prose based skill is that the agent kind of has to figure out every time, like reread, reinterpret, figure out, okay, what are the entities, what are the canonical things here, and especially over time is where this starts to break down, right? And so what happens if you have one piece of the skill that you want to edit or maintain? Well, you don't really have an understanding of where throughout the skill that one piece is referenced, and that can make this really difficult to evolve and manage your skills going forward over time. So that's one thing. These are some results from the paper. They used the skills bench benchmark and found statistically significant higher pass rate, and skills that failed as pros had a greater chance of succeeding using the APE format. So like interesting research there. What we've tried to do is for sure. Yeah, Zach and Jim have been putting out some good stuff. So I would encourage folks to check out the paper. We've tried taking some of these ideas and implemented them in our Neo4j agent memory tooling with skill distillation and skill governance. So let me talk maybe just a little bit about how this works, and then we'll take a look at it live. But the basic idea is taking that memory graph that we talked through, right? So we have short-term, long-term reasoning memory. Can we sort of use the the entities and the reasoning memory to distill in the skill format, but represented as a graph using that ape structure. Can we sort of distill knowledge that we've gained through these conversational experiences, and then can we actually ground these skills in the observed data so that maybe as that data changes in our memory graph, we could then we can realize that, oh, this skill has drifted. The data in our memory graph has changed. Does that change, the underlying content of the skill? So that sort of skill governance over time. And there are a few things in there for constructing the skill. We borrowed some best practices from that Anthropic publishes, and also some other research in the field to look at. Okay, we want to make sure that a good portion of our skill is grounded in actual data. We want to make sure that this idea of coherence, for example, like if we have a bunch of diverse topics in one skill, like maybe that's an indication we want to break that up into multiple skills. And so we use graph algorithms there. We do community detection to make sure we're not trying to bridge like topics from too many communities, and so on. There's once you've distilled a skill, and we'll see this in action in a second, there's like a review pipeline and this sort of thing. And we're going to look at this in the Neo4j agent memory service, where we're sort of treating that as almost like a discovery endpoint, or like a dynamic loading API for your agents to fetch skills sort of on demand. And then we can see there's the ability to check and see if a skill is still current, or also we have some background process running that will notify when your skills are out of date. Cool. So let's see this in action. This is what I'm going to show you is our Neo4j agent memory service, which is a labs project that takes some of the patterns and concepts from the Neo4j agent memory package and puts that in a hosted service. So you get hosted MCP and HTTP endpoints. It is live now, so anyone can check that out. It's memory.neo4jlabs.com is the URL for that. This is the basic architecture. Maybe let's see what this looks like to give you a little context before we dive into any more detail. So this is the dashboard for the Neo4j agent memory service, which we affectionately call NAMS. Anyone using NAMS? Curious, and let us know in the chat if you've tried it out before. Very curious, folks' experience with that so far. And so the idea here with NAMS is I have a hosted agent memory service with a like REST API that I can use to store short-term memory, so conversations, and then that kicks off a background entity resolution knowledge graph construction process that is constructing the graph. There's background observational memory process that's running, kind of like curation and summarization, but similar for reasoning memory. And then what we're going to look at today is the skill generation stuff. And so there's REST API and MCP tools that map to that REST API as well. And then there's also, for example, like TypeScript and Python clients for NAMS that integrate with the different agent frameworks. So I have in this workspace here, I have a few different workspaces. This is my health skills registry. And so I have ingested some messages, some conversations related to healthcare. So we have like new patients authorization. Basically, I think this is kind of going through the process of checking in a patient and pulling their records essentially for like some healthcare provider visit. So the ontology piece comes in here in that I have let me zoom out a bit. I think we're zoomed in a little bit too much. There we go. So we have a healthcare ontology loaded. This comes from our create context graph ontology library, which has just a bunch of different domains. And the idea is we can tweak these or we can import these from different systems as well. But we've loaded the healthcare ontology and we've ingested these messages, and so we can see like here's the piece of the graph that has been constructed based on these conversations. This is our sort of memory graph, and we can kind of scroll through here to see like how this is represented as the graph. But what we want to focus on is the distill a skill feature. So we haven't distilled any skills yet. So in the skill tab, the first thing we want to do is like what is the entry point around this, and we can anchor this around like a specific node. We could anchor this around like patients, or we could do this around a specific conversation. So I'm going to select one of our most recent conversations. We'll do this for all users. And so this is kicking off at our skill distillation pipeline. And so essentially what we're doing is we're starting with that grounding spot. Let me find we have the slide for that somewhere right here. This is exactly what we're doing. So we define the scope, and then we're making sure that the entities that we're traversing from that starting point, that they're not currently going through some processing. So we take a lock on that and kind of build up the graph that's needed to then construct the APE, the agent protocol representation, the graph representation of our skill. And most of these are deterministic. Like the system is written in Go, and so most of these steps are deterministic code. But there is one piece that goes through the LLM, and this is mainly for the annotation, right? So each of these skill subgraph pieces, right, get annotated by the LLM, and it's all grounded in the entities that we found. So let's see how we did. Is this still cool? So we distilled a skill. It's in review. We can go through the review process. And so from that conversation, this was about obtaining prior authorization for treatment of some medication. And so we can see here these steps. These are grounded in the data, and that they're grounded in like actual tool calls that happened to resolve the conversation, right? And so we verify eligibility, check medical necessity, submit the form, get the decision, notify the outcome, right? Like that's and we can see here like specifically what are the tool calls that we need to do that. And here's our markdown skill.md. We can download this as that in that bundle, or we can also use an endpoint for our agents to fetch that dynamically. So let's go ahead and approve. So our skill is now published. Oh, then there's also the ability, right, to assign a key to cryptographically sign these, right, so that we know they're not.
Okay, good.
Cool. So that is distilling the skill. I'm going to kick off a little script here that is going to submit some more messages, and that's going to change the underlying entity. So if we take a look here, we've submitted now some new messages, and that's going to run. Looks like we're sending quite a few. And so that's going to go in and change the underlying tools may change then, and basically like what we're seeing is that like the structure of now how the prior authorization that data is going to be flagged as, oh, this is something that we may want to rederive our skill. We can see how that works here. Maybe this was a little more obvious, and we can look at this in the graph in a minute. Is our skill like has a version, right? Like it's very important that we're able to version these, and that version of the skill is how we represent the skill components and the steps. And so like a skill step, this is the structure that we borrow from the ape paper. We can then ground those in the tool calls, and so each step in the ape paper, these steps are mapped to scripts, so like Python code or something. With NAMs, with the near agent memory service, we don't execute the tools, right? It's just meant to inspect and capture that. Think of that as of more like an observability thing. So rather than mapping to a script or some like executable Python code, we're able to map to the tool call, and each step has a like success criteria which we can observe from the result of a tool call. But when there's an error then that's some indication the skill, because we've made a tool call that's our entity, right? Our skill component can be that entity changes based on new information that's come into the graph that may indicate that that our skill has drifted. So let's go back into NAMs and we'll see here. Let's see what happens now. If we go into skills, we don't have an indication that this has drifted. So we don't have any drift yet. My script may have broken. But imagine that that our underlying memory has changed, and this prior authorization skill is flagged perhaps as needing to be redistilled. We can come in here and kick that off, or we can also do this programmatically as well. And then that would update the skill, and we would go through again that same review process. I think we would.
And then can you repeat again how the drift detection works? How?
For sure. Yeah. Let's look at the database and we can see how the actual data is stored. So, or this one, I think this is our underlying database. Let's see if that's the right password or not. Okay, I think this is our database. Cool. So here's how we're actually storing the data that got distilled here. Mm-hmm. So here's our skill version. And we can see here, these are pieces of data that this was distilled from, including the tool calls and the entities used. And so what happens is, let's say if this tool call, we can expand out to see, in this case, we only have the single agent that we're interacting with, but imagine that we have hundreds of other agents in our system, and they record tool call results that represent like an error state, right? For this auth status tool.
Oh,
This
okay.
is
Yeah.
this is calling out
Yeah.
to some like third-party system to fetch the
I
status
see.
for, I don't know, like some pre-authorization for some like healthcare insurance. And so now imagine that some other tool some other agent finds that, oh, this tool appears to be broken. That would then be an indication that our skill, which requires this tool, may be broken or may be stale if this tool is no longer functional, or similar to this Dr. Nguyen entity, right? So if the information related to this entity could be changed by some other agent, then this skill is grounded in this entity, and so our skill that we've grounded will be flagged as, oh, the underlying data that this skill is grounded in may have changed, so you may need to redistill or review the skill. And that's the idea of the governance piece, which is over time, because we've modeled this skill as a graph, we can see changes in the underlying dependencies of the skill and capture that immediately as the underlying data changes is the idea. So that's one of the benefits that we get of modeling our data or modeling our skill as a graph.
Very cool. Thank you.
Cool. So yeah, so that's a look at the skill distillation stuff in NAMS. I think that's most of what I wanted to show. And again, in the slides here, which we'll link if we haven't already. So some more advanced things we can do, like we can have skills that call other skills, right? So we didn't get flagged when we went to distill this skill, but if we did something like, if we tried to say, okay, let's distill a skill for the entire workspace, we'll see what happens here, but we should get a message that says like, hey, you're trying to distill into a single skill like a whole bunch of topics. Let's try to break this up into multiple skills, and then we would see those skills become sort of dependencies of other skills. So think of a graph of skills, perhaps. Cool. So Alex shared the slides there. I think that's kind of all I wanted to talk about, but I will end on this slide that just has some additional resources. We've probably shared or talked about most of these. I think the most relevant ones here are the Near4j Agent Memory Service, memory.near4jlabs.com, which is that's NAMS. That's the application that I was showing how to use agent memory and context graph to construct skills and govern those. That was the application we were looking at there. But yeah, there's a lot of good stuff on Graph Academy as well. I know we have an agent memory course, and I know that the Graph Academy folks were recently updating some of the content there. So that's always a fresh, good one to look at as well.
Definitely. Yeah, definitely. Cool. Very, very, very cool. Thank you very much, Will. There are two questions. I know we are approaching the end of the slot here, but maybe we can look into those. 9inch asks about the drifting. I think how are the changes triggered manually, or gets the system events on changes?
Yeah, it's pretty. Currently, it is. I think I have a slide on this. Somewhat manual. So there's a background process that's checking this, that can be configured. Currently, it runs I think once an hour or something like that, and then we can also check for any skill to check its status, which will re-trigger that. And I think when you have the skill tab open, I think each of those is polling. So you should get refresh state there. So yeah, so it's not using like database triggers or something like that, which we could certainly do to look at, like CDC or something like that. We could certainly explore that. But yeah, currently it's this kind of push or pull manual process.
Cool. And then the other question comes from Darlan, and I think maybe we didn't introduce NAMs properly enough. He says, looking at a screen full of names like PA229, memory types, confidence, and graphs, what exactly is this NAMs memory browser thing, and how could it serve as a memory for an AI agent to carry out a task or a skill? So
totally,
maybe if you could give a brief overview.
Yeah. Totally. Yeah. We just jumped right in there. So NAMS is the Neo4j Agent Memory Service. This is a hosted project as part of our Neo4j Labs team. So this is an experimental kind of project that's out there to use and get started with, that implements some of these patterns. We don't sell this or officially support it. This is built on the Neo4j Agent Memory tooling, which is open source. You can find that in the Neo4j Labs GitHub org. And so the point of NAMS is to provide hosted service, both hosted MCP and REST API, that allows you to plug in short-term, long-term, and reasoning memory to your agent. There are, bring up the docs page for this, neo4j.com labs agent memory. There are also SDKs for TypeScript and Python that integrate with the different TypeScript and Python agent frameworks there. So you don't need to use the MCP tools directly. And then the idea is by storing short-term memory, so like conversations with an agent, both user and assistant messages, those can then go through this entity extraction pipeline to build up the long-term memory graph. And as we saw here in the memory browser, this is the like graph representation, and it's like a truncated view, but we can see like the entities that have been extracted from conversations and how those are connected. So PA2208, this is a specific diagnosis in this case, and so that came from the like medical ontology that we have, has a diagnosis as one of the types that we want to extract out of conversation. So anyway, so that that gives us kind of like a structured knowledge graph based on our based on conversations, and then there's also some background curation process that's running as part of observational memory, which is surfacing like summarizations and insights as well. And so that's kind of the core functionality of NAMS, is building up this knowledge graph of interactions with the agent, and then making that knowledge graph available to your agent during the agent reasoning phase through like MCP tools, which can then allow the agent to do vector and graph retrieval to fetch data that's most relevant during its reasoning phase, to improve how the agent functions going forward. That's the general idea of NAMS in maybe about a 30-second overview. But there's a blog post. Let me find the link for that has a bit more info. Here we go. This one here.
Perfect.
Is tour of the Neo4j Agent Memory Service. Just kind of introduces some of the features and why we built it and that sort of thing. So that's maybe a good place to start if you want a bit more info, or you can you can just kind of sign in and give it a try. But yeah, let us know what you think. There's a feedback button on every page in NAMS. So as you're using NAMS, this little guy here, just click that guy and submit any feedback you have. We're actively working on this and curious, what feedbacks folks have. We're adding some more features to the skills distillation piece, but as I said, that's a bit more experimental. So as folks work with that, that's the piece I think that I would really love to see if that's useful. How folks are getting on with the skills. We're looking now at sort of better benchmarks and evals to demonstrate that this is useful beyond some of the initial research that Zach and Jim did.
Very cool. And I know we're over time, but maybe quickly one more question from Ghazi. Ghazi asks, are these capabilities available in self-hosted agent memory?
Good question. So we said that, where's the docs? Here's the docs. Yeah, so in our agent memory, we have the agent memory Python package, and then the hosted NAMS service, where we have like TypeScript and Python clients for that. And so the question is, if I'm using this self-hosted option, the Neo4j agent memory package, do I have this like skills distillation functionality? The short answer is no, not currently. There are a couple of things too that are in the self-hosted that are not in. I'm sorry, a couple of things that are in NAMS that are not in the Neo4j agent memory package. One of those is the observational memory piece. The other is the skill distillation. And the reason for that is just that with the Neo4j agent memory Python package is you're responsible for running like the entity extraction pipeline. So like that's all in the Neo4j agent memory Python package, and it's quite heavy. And then things like the observational memory piece and the skills stuff has some like background curation job, so you kind of need like a running service there. And the Python package is it's meant to be the memory piece that you add into on top of your other agent code, and so it's a little heavy. And so I don't know, I'm not sure. We may open source some pieces of NAMS just to make it easier for folks to run. There's no reason I think that we have it in the hosted service and not the self-hosted version, other than it's just not a good fit for something that's just meant to be a package that you include in your AI agent app code. So yeah, if folks are wanting to self-host that piece of it, yeah, maybe that would be a good iteration we could do, is figure out the right way to package that up. Yeah, so that'd be super useful feedback to hear from folks. Certainly something we can do.
Nice. Yeah, let us know. Feedback is always welcome, especially for these kind of early experimental early development prototype kind of labs projects, where we obviously experiment and see. We think it's useful. We think it's something that people will like, and we think it's something that is adding value. But obviously the proof is coming from your usage, from your feedback, from how you think it's helping you build successful AI applications with graphs. Cool.
Sure.
Yeah, I think that brings us to the end. Quickly, I'd like to announce the next stream that's taking place on the 22nd of July. So we'll take a little break next week. Olga and Stu, colleagues of ours, will talk about network intrusion detection with Neo4j and Snowflake. So that should be a fun and interesting session in 2 weeks' time. And obviously notes. Yeah, I'd like to leave you here with this. link. I think Will also mentioned Graph Academy before. Neo4j Aura, we mentioned this as well. If you want to start with Neo4j, this is a nice place, especially nowadays. You have something like document intelligence available on it. So if you just wanna throw a bunch of PDFs or unstructured data into a graph and see how it goes, and have a chatbot basically at the end of it, this is a super quick, almost, I would say, no code solution that gives you a quick turnaround on something like, is this something you're interested in? And if you want to talk to us, go on to the Neo4j developer pages where you find the community, resources, documentations, all the things. And yeah, reach out. If you build something cool, tag us. If you build something and stuck with something, also tag us, let us know. And if you have feedback on this episode, on other episodes, on general Neo4j products, then also we'd like to hear from you. And yeah, with that, I think we're at the end of today's episode. Thank you very much, Will, for jumping in for Jesus. And I'd like to, hope to see you all around at one of the next episodes coming up in the future, or at an event in person. So, for example, I'm heading to Berlin for VR Developers tomorrow. So if you're around, come by our booth Thursday, Friday, and say hi, and let's discuss graphs. And yeah, with that, thank you all.
Awesome. Good to see everyone. And yeah, thanks so much. See you next time.